Assalamu alaikum. Today we will start with chapter 4 with the title Differentiation. Section 4.1, the derivative of a function. The objectives of this section are: recognize the notation f prime and dy by dx for the derivative of the function. Find the derivatives of the power functions. If you look at this graph, this is a graph of a function, and you can see there are some straight lines. These are the line tangent of the graph of the function at different values of x. Let's say this horizontal line is the line tangent at x equals 0. This is another line tangent at different values of x, and this is also one more line tangent at different values of x, and so on. So the slope of this line, the slope of the tangent line of a function at a certain value of x, is called the derivative of the function. So if we find the slope of this line, which is the line tangent at this point at x equals 0, this will be the derivative of the function at x equals 0. The slope of the line tangent at this value of x is different from the slope of the line tangent at the previous value of x, and this slope gives us the derivative of the function at this value of x. So the derivative of the function always equivalent to the slope of the line tangent at certain value of x. Now it's interesting to notice that corresponding to each value of x, there is a uniquely defined derivative of the function, and we use this symbol or this notation for the derivative of the function f prime x, f prime x. Another alternative notation of the derivative of the function is dy by dx. We read it dy by dx. We write it like this. So either f prime x or dy by dx. These are the common notations for the derivative of the function. Let's start with the first rule of differentiation. We call it the power rule of differentiation. So the rule says if f of x equals x index n, a function, this is a power function, then its derivative f prime x equals n multiplied by x index n minus 1. So if we would like to find the derivative of such a function, which is a power function, x power n, then its derivative will be n times x index n minus 1. So the process of finding the derivative of the function is called differentiation. So normally the question will ask you either find the derivative of the function or differentiate the function. Both of them are asking you to find the derivative of the function. So the process of applying this power rule is very simple. What you need to do is you bring down the power n. So the power n, you bring it in front of x, and then the power of x becomes now n minus 1. You subtract 1 from the index or the power of x. You will get the differentiation or the derivative of the function. So if f of x equals x index n, then its derivative f prime x equals n times x index n minus 1. Now the value of this index n might be positive, it might be negative, it might be an integer, it might be a rational number. So there are different cases, and for each case we will handle some examples now. But the general rule here applies to all cases. Let's start with case number 1. If the power here n is a positive integer, like if the function f of x equals x squared, then its derivative f prime x equals 2, you bring 2 in front of x, and then becomes 2x. And the new power of x becomes 2 minus 1. You subtract 1 from 2. So 2 times x power 1, that is 2x. So the derivative of the function x squared is equal to 2x. This is another example. If f of x equals x power 15, then its derivative will be 15 times x to the power of 15 minus 1, i.e. 15 times x to the power of 14. So this is the way we use the power rule if the index is positive. Now, if the index is negative number, then we apply the rule also. The power of x is brought down in front of x like this, minus 3 times x, and we subtract 1 from minus 3, it becomes minus 3 minus 1, that is minus 4. So the answer will be minus 3 times x index minus 4. Okay? Sometimes the function will be given like this, 1 divided by x index 6. So we can bring x index 6 up to the numerator, it becomes x index minus 6. And then for its derivative, we apply the power rule, it becomes, or we will get the derivative as minus 6, x index minus 7. Here we have some examples for differentiating these functions. We will discuss in details the derivative of these functions in the class. Now case number 3, if the power is a positive fraction, like if f of x equals x to the power of 3 halves, again we are applying the same rule, power rule. So we'll bring the 3 halves in front of x, and then the new power of x is 3 by 2 minus 1. So we have to subtract 3 by 2 minus 1, you will get half. So the derivative of the function will be 3 by 2 times x power half. This will help us to find the derivative of the function with a root, like this function, f of x equals the 5th root of x index 8. As we learned in the previous sections, this root can be converted to an index using this the formula here. So the nth root of x index m equals x to the power of m by n, and then we apply the power rule to find the derivative of this function. So the answer will be 8 by 5 times x to the power 3 over 5. We will explain this in more details during our class. Now case number 4, if the power is a negative fraction, we will apply the same formula. Okay, the power is brought in front of x, it's minus 3 by 5, and then the new power of x will be minus 3 by 5 minus 1, and we will get this answer. Okay. So these also some examples on the power of a negative fraction. Here we have some examples. All these examples will be discussed during the class. Now, this case is if the function is constant function. Constant function means a number. If f(x) equals a constant, like f(x) equals half, equals 100, or pi over 2, or square root of 1000, all these functions are called constant functions. So the derivative of the constant function is always 0. Keep in your mind that the derivative of any constant function is 0. Now, let's say the function sometimes the power function is multiplied by a constant, like this, if f of x equals c multiplied by x index n, where c here is a real number, okay, and x index n is a power function, then the derivative of this kind of function is we bring n in front of cx, it becomes c multiplied by n multiplied by x, and the new power of x will be n minus 1. Okay, so the difference between this case and the previous case is we have a number here, a constant multiplied by x. So this will not change anything in the derivative, in the differentiation rule. We just multiply the power n by this constant c. As an example, let's see if we have this function f of x equals 10 times x index 4. So the derivative will be, we bring 4 in front of 10, we multiply it by 10. So it becomes 4 times 10 times x, and the new power of x will be 4 minus 1, that is 3. So 4 times 10 is 40 times x to the power of 3. Here we have one more example, minus 4 divided by x squared. So this function we can write it as minus 4 times x to the power of minus 2. And the derivative of this function will be minus 4 multiplied by the index minus 2 multiplied by x. The new index of x is minus 2 minus 1, that is minus 3. So the final answer will be 8 multiplied by x index minus 3. Let's say if we have a function like this, f of x equals m multiplied by x. M is a constant and x has a power of 1. So its derivative is m, because the derivative of x is 1. And here we have some examples, like f of x equals 6x, its derivative is 6. If f of x equals 5 by 2x, then its derivative 5 by 2. If f of x equals x by 3, then its derivative is 1 by 3, and so on. Here we have some examples. We'll discuss these examples during the class. Also, these examples will be discussed in the class. Here in these kind of examples, we have different functions added or subtracted with each other. So the way we differentiate this function, this kind of function, is we differentiate each term as a separate function. So we'll find the derivative of the first term plus the derivative of the second term minus the derivative of the third term plus the derivative of the fourth term, and so on. We will discuss these examples in more details during our class. Okay? Thank you very much. I will see you during the class, inshallah. Bye-bye.